The camera is not working. So I get to figure out why that is before I can do any work. I mean, why would I want to do any programming work? The very idea is ridiculous. Okay, there we go. So the deal there is I run a software webcam splitter because Windows doesn't let you let more than one program see a camera through the miracle of Direct Show or whatever it is still behind the scenes. That webcam splitter, which has a very simple job, well, it is a piece of software and it's the year 2020, so it failed and just didn't give the image out anymore. So I had to shut down the webcam splitter and then set OBS to the actual camera because I don't right now need to split it. So I'm able to do that. Able to do that. Is the camera a Sony A7 III? Yes, it is. That is what it is. It is a camera. All I have to do to finish making this little demo work is make... Okay, we made this work off stream, so we're going to make this work. Wait. This is wrong. This is not what I'm working on right now, but this is wrong. What am I looking at? Okay, we're good. I know what this is supposed to be, and that's not what it is. But we're not going to fix that yet. We're going to fix this. Where was this thing we were doing yesterday? Here we go. If it's a constant pointer. Okay. Hold on. Yeah, this is all if we're in star. I need to add this. So we actually want both of these to work, I guess. Okay. Sub, right. And then, we're going to do this. I'm going to be so cheeky right now. I'm going to be so cheeky. Cheeky breaky. Although, I'm realizing this might be annoying. You know, I start to do a feature and then I realize that it interacts with other features and like, oh man. I guess it's fine. I have to write this frickin' thing. Maybe I don't want to. Maybe I don't want. Maybe it's not worth it. But actually, it is worth it. All right, we're going to power through. Does the compiler adhere to the solid print? No. Like I even know what that is. Do I think I'd be working on stuff like register allocation before the compiler is released? I would expect that before the compiler is released, we will have a register allocator on the x64 backend, but it won't be like, you know, good, right? It won't be a really smart register allocator, but it'll be better than the nothing that we have there right now. Because it's actually like, you know, implementing, for example, a LIFO register allocator or LIFO with a couple tweaks. It's like, well, you know, LIFO is known not to perform that well, broadly speaking, compared to more complicated strategies, but it performs a lot better than not having register allocation. So, yeah, that's a thing that'll happen. Have I implemented a regex engine in the past? Not ever a full real one. I might have done a little bit of a toy one at some time. Solid is OOP stuff. All right, well, this definitely does not adhere to the solid principles. Definitely. Does anyone think I am a tad low? Well, the volume, I mean, it's on some number of decibels, and OBS, let me see if there's like a global. Okay, there is like a -1 decibel here. So we could put 0. Oh, that's just the same as the regular volume slider. Well, I was clearly minus 1 decibel. Apart from that, I don't know what you want. Like, if I look at the OBS mic aux thing here, it's like up in the yellow and occasionally in the red, which should mean it's almost clipping. So that should, according to the Rainbow Skittles colors, be an appropriate mic level. So if it isn't, I don't know what to say about that. Like, I mean, we're in the yellow most of the time when I'm talking, right? Do windsock bindings already exist? I don't know. Somebody might have done them. I was going to do them at one point and didn't. Any chance the beta is getting the people to switch their companies over to the new language? No, because the beta is way too small right now. The beta is like 20 people. That's not enough to have a company switch their programming language. Maybe your headphones are just not very loud. How am I feeling? I did not get enough sleep last night. So usually I drink caffeine and it has no effect on me, but once in a while I drink a little too much and then I just wake up. So like I got half an hour of sleep last night and then I woke up and then I was up until 4:30 a.m. and then I finally got like 5 hours of sleep. So that's where I'm at right now. And that is always the best for programming quality, as you know. Have I thought about anything that would help people with taking pointers to a dynamic array that might grow and making sure you don't get bitten by an invalid pointer? Well, I mean, just use an array that doesn't relocate, right? I mean, you could use a bucket array instead of a resizing array. It's just that, you know, you then pay a little bit to subscript it, but it's not that much. And, you know, you may make that back in terms of, you know, you're not paying to copy the data all the time, right? So can you ask what beta members use the language for? I don't know. Everyone's sort of doing their own thing with it, right? There's people doing stuff. Or virtual arena array. Yeah, I guess so. Like, it's just, you don't want to have 10,000 of those in your program, right? Like, if you have like one array or like 10 arrays, it's good to do that, but I don't know. Okay, so the thing that I'm dreading here, I was starting to do this code where it's like, hey, we'll figure out the offset of a member of a struct. And then I realized, oh, dude, it has to like, we have to deal with using and all that. Which is a big butt pain. That said, you know, you would like to be able to provide a primitive later, like a built-in like offset of that tells you the offset of a member. So I should just knuckle down and do it. The problem is this means I may not ship the beta till late tonight because I was going to do this and then just do some documentation, and it may be harder than all that. kind of crazy how much code I write that works without a ton of testing. I mean, that's just experience. I mean, honestly, I've been programming for 38 years. If you don't think that you would get better at programming after doing it for 38 years, then then that's a bleak picture of the world, right? All right, so for some brain power to help me power through this, I'm going to toast a pretzel roll and then get some more caffeine, because caffeine was my problem, and obviously the way to solve that problem is to do more caffeine. Do I do ASAN builds ever for the compiler? I've done them occasionally, like, actually, no, not really. ASAN doesn't help us much. I was doing some TSAN builds a while back when I had some race condition problems, and TSAN helped a little bit, but it didn't help that much. So I'm interested in the long run about figuring out how to make that kind of reporting more useful. Because like eventually, like I solved the really bad race, like TSAN helped me find some more minor race conditions really easily, but the big one that was screwing me up, it didn't really help with. It didn't help me figure out what it was, and I wasn't sure if those reports were false positives or not. It turns out they weren't, but I don't know. It's not as easy as just running it and seeing the problems. Whereas something like ASAN, historically, it's a lot easier to tell what the real problems are, you know. A little bit of mustard? No, I'm gonna toast it. It's toast. Maybe some butter. Maybe ship beta title from yesterday, just a joke. No, it's not a joke, but it's a closed beta. We're not shipping open beta today. Why is everyone so presumptuous? How is it possible to have a pointer in the .data section to some other place in the .data section? How would it even work in a position-independent executable which don't have a relocation table? Are you sure that's correct? What doesn't have a relocation table? tea and the toast are going. Do I think people have become more aware of low-level programming efficiency thanks to the Handmade Network, including talks from me and Casey? I mean, definitely some people have, because we've gotten, nice letters from people and stuff. What percentage of programmers globally is that? And is the field of programmers growing faster than those people are increasing? Maybe. All right, everybody. I got some pretzel rolls. I got some tea that we better not oversteep because, oh my God, too much caffeine is going to be bad today. Any thoughts on Blizzard 2.0, aka Dreamhaven? I have no idea what that is. People assume that I know things. If I'm going to be completely honest, though, I was not that into Blizzard 1.0. Like, those games were never really my kind of games. So if Blizzard 2.0 is doing the same kind of thing that Blizzard 1.0 did, I mean, that's great for other people, but it's not really my thing, And that's fine. Like, that's not to diss it or anything. It's just not my thing. Do I think Rust has a future in game programming? Not really, no. I could be wrong about that again, but I don't think so. Would there be any way to improve that kind of race detection from a language perspective? I mean, well, there's basic features that you can add that reduce the need for it, right? And some languages have done this, I'm sure. So you can do something like say, look, here's a general abstraction of a mutex-like thing. And when you declare a variable, you say this mutex has to be held in order to access this variable, right? And then, that's, sorry, I'm still waking up. That generates, in a debug build, that generates code that asserts if that thing isn't held, right? And in a release build, it doesn't, right? That reduces your need to have to lean on a race detector like that to find all your problems. Another example, have much better control over namespaces so that if I have some code that's threaded, I absolutely know that it's not allowed to access global variables anyway, right? Then I can have a great degree of confidence that there's not some hidden race condition between that and some other thing somewhere, right? Again, that's better than something like TSAN because it's more like the high level of confidence and morale that you get from something like static type checking. How much time do I think is healthy to spend on a computer? 2 hours a day, not in one contiguous block. How is Lake Tahoe? I didn't make it over there yet because California burned. Thank you for not oversteeping my tea. Do I think bigger companies will eventually start applying principles promoted by me and Casey? I don't know. I mean, in order for me to believe that they would, I would have to think that they actually care to a great degree about how good of a job that they are doing at programming. And I don't see evidence of that. Right? Like even that, like it's not like companies really deep down super care about how good a job they're doing at programming and they just have a difference of opinion. It's actually, they don't in reality care that much. They'll claim they care, but demonstrably they do not. And so if that isn't fixed, what are you going to do? Because if you cared, you would actually measure and iterate and improve. It's not that hard. But people don't, or large organizations don't. What game development project excites me? I mean, honestly, it's hard to come up with one that you wouldn't already know because I already talk about it because, I mean, most games are pretty boring, right? If you've been playing video games for 40 something years, most games are pretty boring. Monsters Exhibition was nice. In part because I didn't expect it to be as good as it was, because when I played the demo was just really easy and didn't seem to get to the good part of the game. But the full game was actually quite nice. So that's a recent one that I did like. But looking forward to things like coming in the next year, I don't know. But that also might be a function of the fact that it's just a very noisy environment right now. And how would you know if a game that you were really interested in was going to come out? Do I use a library for the lever? I have no idea what that means. Do I think the U.S. is falling behind in terms of quality software engineers? I don't know, right? Because there are two different things. There are, okay, is the quality of software in the U.S. decreasing? Yes. Is it also decreasing everywhere else as fast or faster as in the U.S.? Probably. Like, it's not like I see other places with brilliant ideas about how to do more robust, higher quality software. Like, the U.S. is still leading software. It's just it's doing a terrible job at it. So I don't think the U.S. is falling behind. I think everybody is falling behind. A grammar mistake at the end of the third comment. It's pretty straightforward for the compiler to know the address of a member of a struct literal. So it's what, this comma? I mean, that's fine. It's actually correct either way, but you know. Do I use a library for the Lexer? No. There's no reason to use a library for a Lexer. Should I get the new Xbox or the new PlayStation? I mean, get the console that you want. I know which console I will buy first, but I'm not going to say. Double is really. It's easy for us to guarantee that it. See, I knew what it was supposed to say, so my brain didn't even see it. Can we target instruction sets other than x64 yet? Yeah, we did ARM a little bit. Someone on the team did ARM for Nintendo Switch, but we haven't really followed up on that. That was more like an experiment than a serious thing. Is this falling behind globally similar to the academic falling behind lack of quality discussed in Imposters in the Temple? I don't remember exactly what Imposters in the Temple is, or if I've read it or not. It's probably related, but not the same, right? It's related in the sense that the criteria for success are not coupled to quality. And anytime that happens over a long period of time, things will go downhill because there's no reason to keep quality high, right? So it is actually vital in any society to make sure that success is coupled to quality or long-term good outcomes, right? Like anytime that goes away, you have serious problems. Switch is ARM. I'm pretty sure Switch is ARM, right? Isn't it? Isn't Switch similar to an NVIDIA whatchamacallit, but slightly more beefed up? Yeah. So it's LLVM did most of that work for us, obviously, which is another nice reason to have it. Shield, yes, correct. Because you had ARM hardware issues on it. All right. Okay. So I'm doing this stuff about if you take the address of a member of a global struct or of a struct literal, those are constant at compile time. Those become constant pointers. This means we can also do offset of later. Can this language do operating system development? Yes. Is the PS5 still based on FreeBSD? I don't actually know. As much as I am an enthusiast of the next console hardware generation, I've been too busy doing stuff like this to do, like, you know, down and dirty machine specific programming on those consoles. Okay. Well, let's just start. We'll start with the easy and move on. All right, so if we get here, yeah, all right. So we're just going to say global symbol offset equals offset of final. Actually, okay, hold on. This doesn't, okay, this is binary. This is binary left, all right. Okay, so we have an identifier and we have a declaration on the left. Actually, no. What am I doing? Okay, we're going to do that. We're going to get the offset of all right. Oh my gosh, there's so many butt pains here that I'm thinking of. We have to do no check-in test dereference of member of the module. That's essentially a global, but it's not one that we're dealing with yet. Oh my gosh. Didn't even. Where does sub come from? Oh, right there. We got a substitute right there. All right. Okay, back to the thing that we were doing, which was down here. It's getting warm in my apartment. So what's happening right now? Basically, I'll make this easier to understand. So we're trying to make the following thing work. Where is it? This file is just like a test/demo file of all the things that are constant at compile time, and we want to make these things work, right? So if you take the address of a struct member that's in global space, right? That's just the same as adding an offset to the pointer, right? And we already did that. So we obviously have the backend capability for this. So we're just making sure that if you do this in your code, that gets crunched down at compile time into a constant pointer. Now the code that we're editing right now is the code that does type checking for this operator, the address of operator. And type checking is where we also do constant expression evaluation, because if you want to boil down a constant expression to something simpler, you want to do that before you go code generate the thing that you're crunching down, right? The whole point is to avoid code generation for that thing. So we're in the type checking code for this thing, and we're saying if the thing that we're taking the address of is a binary dereference operator, then do some stuff, right? And so the stuff we're doing is saying, well, if the thing on the left is a struct, right, because it could be other things. I'm thinking of other stuff that we have to test. No check-in, test address of okay. Honestly, this is kind of annoying. Compilers are annoying when you're trying to do a good job. Okay. So the thing that I don't like, this is getting complicated in several ways. So we're basically saying, look, if it's a dereference, then see what is being dereferenced there. And the problem is, we have to deal with usings and stuff, which shouldn't be that big of a problem because we have to do that during code generation anyway. So we do it, we just have to do it in a similar way in a different place. So that's annoying. And we have to deal with all the dereferences of types that are not exactly structs. So like the built-in string and array and all these things, it almost makes me want to punt on this and work on more important issues. Except that it's maybe actually not that hard if I restructure it a little bit, because we will have already done this work. For us to get here, we have to have done all the type inference on the thing. And so like we actually know we did all the work to correctly handle most of those cases. The using one, not really. Do I have an opinion on data flow oriented programming languages? I have no idea what that even means. Okay. So the thing about programming language design that you guys have to realize is that even if something doesn't seem to be designed by committee, in the modern internet environment, it will be designed by committee a lot of the time, because if you just listen to complaints of people on the internet and do what they tell you to do, you're doing design by committee, right? So if a programming language operates by being responsive to the community in terms of what people want, then it's designed by committee, and you're going to get a design by committee kind of result. That's just facts. That's the fact, Jack. Do I usually get 8 hours of sleep a night? Yes. Isn't data flow oriented programming what I do? I don't know. Probably not. Probably not. Okay. Actually, no. We're just going to do this. Oh, I forgot to check also. No. That's fine. So we make a global symbol. We need to set this thing offset from symbol. But however, if offset of fails, I need the ident there. Okay. Cannot type right now at all. So we're going to put this up here. We have this now. So let's take a look for a second at the other thing that does this work when you actually do a dereference. So like this pretend struct definition is, gets filled in with like, hey, it's an array or it's a string or whatever, right? And like, if we just save this information somewhere, or instead of saving it, we can just factor it out and call it again. Problem is, this is not really factored to do that. Like, so I could factor out the thing that says, hey, get this for the given type, but this is like doing constant expression evaluation also. Oh, we actually have this. Okay, so I guess I factored that already. I did. Wow, okay. So this wasn't as bad as I thought. It's also called in global data, which is probably why I factored it originally. All right, so yeah, so these are all things that we cache from the preload that are the structs that represent the different things. Very easy. Very easy. Okay. Now what? Well, we can write this offset of. And I'm just going to start by returning 0 because I want to make sure this compiles because it's been a little bit since we did that. Return 0. We actually could even just run it and make sure, because we're just returning 0 right now. Operator. All right, and then just move that up there because it's C++. Is there a previous video on how type inference is implemented? I don't know if that's a thing. Like, yeah, if there is, it would be a very early video, but I don't really know if that's a thing because the thesis that this language operates on is that you don't actually want the pointy, sharp-brained type inference that like languages like Haskell or even Swift or whatever do, right? You don't actually want that. Interesting. We didn't get it. In part because it makes your program really slow to compile, and in part because if programmers don't understand very well what is happening, that's just bad for productivity and morale. So type inference is actually mostly very simple, except there's a couple of extra things for usability that make it more complicated, but those things you can ignore as a beginner, right? And we may be able to iron some of them out more. Okay. We can just break here and see. I mean, it's, how is it not this that's failing? But we'll see. Okay, so 3063. And source line uh, 181. Actually, Address of a member of a struct literal. I don't think we actually do. I think we just do this. This one, like, it's up in the air about whether this makes sense. Like, should you... I'm actually going to say that one doesn't make sense. So we're just doing this. Line 181. That's from yesterday. All right. All right, we're in the right file. Binary right type is s-ident, left defin struct desc. I assume it's instantiable, yeah. Final also. How did this not, did we just run the wrong compiler? Address of a member of a global struct. It says not constant. It says not constant. Oh, maybe declaration has global storage. It's not true. Really? Did we pass the wrong declaration? I bet we did. Yeah, we passed the declaration of the member. That is not what we want. Right? So we don't want to know if this has global storage. All right. So there we go. We were being a little nonsensical, and by we, I mean me. Whoops. Okay. Constant address of a member of a global struct. The only problem is that constant is currently the address of the struct, because we're always returning 0 from offset of. So, well, I think we just call find in block from here, right? Or actually, we don't need that. Ident enclosing, or no, ident resolved scope entry and closing scope. Actually, what I was about to assert was not really true. Okay. So let's just start making the offset. So we start with 0, and then we're going to say cursor is ident resolved scope entry while cursor. So this could be like a chain of usings. All right. I don't know. We're not going to handle this yet. Because we just need the dummy solution to get this working at the start. And the dummy solution is assert cursor arrow and closing scope belongs to struct is equal to desk. This is only true until we handle the using, so that's very temporary assertion. Offset plus equals cursor arrow base address break. Okay, so this is the form of a loop. We're not actually looping yet, because the base case that we're handling doesn't have any frickin' usings in it or anything. All right, base address is not, all right. I'm a little sad about this scope entry thing that I did. Okay, oh. If is constant decal interp, or no, ident, attempt to take the address of a constant member of a struct to record info decal. Here is the struct member that is constant. All right. Great. Really? Let's not worry about that yet. It's going to go away anyway. I'm not sure. I put that there. I'm not sure it's right. Okay. So let's just put, so we're going to say print and then we're going to say .x, .f, and .t. Whoops. So okay, .x is the same. .f is 8 bytes later, which makes sense because that's an integer, which is 8 bytes. And then .t is 8 bytes, which again makes sense. So this is 4 bytes, but then we have some padding between that and the next member. So yeah. Actually, we could swap this around. Oh, that wouldn't matter because let's do this. Let's put 2 floats in there just so we can see a difference. Whoops. See a difference of 4 bytes. We want to see some difference because sometimes, as we know from last night's stream, when you see 8 bytes, it's bad. Okay, yeah. So we got a 4. We got a 4 bagger. Yeah. So that works. Now let's do something that doesn't work. Oops. Right? This will not work. Dude, I bleed so hard for features like using that are really nice, but I also understand why C++ doesn't have them, like good using, because You pay for it. All right. We'll go back. Oh, we'll go back over here, and we're going to say address of a member of a global struct through using actually, we'll do two versions of this. Recursively, right? So we should be able to say .sum.g, right? Actually, we actually want this. So we've got global sum other struct and global sum other struct dot t, right? So this one is doing a double deref, and I actually don't think this is going to work right now. Dang it, bro. All right. Well, let's turn off this assert for a bit. Oh, we're asserting on the using, right? That was the point. Let's actually not, okay. Let's not even do this one yet. Because if this one doesn't work, what are we even doing, right? Yeah, it doesn't. So that makes me sad, dude. It just means that what I'm doing has to be more complicated. It's like I'm questioning various life decisions. Like the way that using is implemented is not by desugaring things. If I did implement it by desugaring things, then it would automatically be handled by the complication I have to do this, but that's not how it is. So sometimes I'm designing a video game and it gets really big and complicated and hard to deal with. And then I'm like, oh man, it's really hard to make this video game. But then also I'm like, you know, the fact that this is complicated and hard to deal with is part of what makes a video game interesting and good. And like, The Witness wouldn't be as good of a game if it didn't have all these little details that make it complicated and stuff. And I'm sort of on the fence here, is like, how many people right now really care today if this is the case or not? Probably not that many people, right? So I could just punt this for later, and it would be fine. And my beta users would be happier because they would get the beta sooner, and it would fix their problems. And the code would be simpler for a while. But, and here's the but, and it's a big but, that this kind of attention to detail is what makes this actually a good production quality programming language, and not, you know, one of these languages that people put on the internet with their name on it, right? All the time. So I'm a little bit torn on this. And I'm not sure how to call, like sometimes I just don't know how to call it. Like sometimes I've gone and done really complicated things and then those weren't worth it and I backed them out. But it probably was worth it to go through that process just to figure out that that thing wasn't the right thing. And so when it comes down to something like this, I'm like, in principle, yes, there's absolutely no reason why this shouldn't be constant. Do we want to pay for that in terms of complexity of the system eventually? And then also, do we want to pay for that in terms of complexity of the system right now when I have other things I could be doing too? And I'm not sure. I am not sure. Or, you know, I could even leave it where it is right now. I could take out the assert on usings and I could just say, look, dudes, it works if there's not a using and there's not a recursive dereference. That's just kind of lame, though, honestly. Like, ugh. It's just kind of lame. Let's just take a look at this for a second. Like, part of the value of the language is that we are not lame. Do I know if any of the beta testers are making a serious game project? I don't know of one. Most people are doing smaller stuff than that. Isn't this a requisite to the cool new secret feature? Yes, but the part that we need to as the groundwork for the cool new secret feature is already in there. One beta user says punt in this case. Okay, I'm going to go on it just a little bit more. And let me just see what it looks like, right? Okay, so what we're going to get here is that we're going to go through this. And this is not going to have global storage because this itself is a dereference. Have I done the string stuff of yesterday? No. That is one of the things. So what I was thinking I might do today in a follow-up stream. So in this stream, I just want to finish whatever I'm doing here and like ship the beta, which probably involves a little bit more documentation for the beta people. And then in the afternoon, I want to do, yes, anyone who saw yesterday knows that I was complaining about a lot of architectural things. One of them was the string table thing, but one of them was just the Linux address poking thing, and I kind of want to do that one too. So just like internal cleanups that'll make the compiler nicer today, right? I am very tempted to punt right now because what I have to do here to handle the recursive case is I actually have to flatten out the frickin' thing and then walk over all the identifiers. It's like a whole subsystem just to do this one feature. And, okay, here's the thing though. This is also something that you could implement yourself. Like you can write offset of in the language itself. So like, should it be in the compiler at all? Like maybe in terms of the principle of keeping the core system as simple as possible, they shouldn't just be in the compiler at all. The problem is then you don't get a constant pointer in this case, right? All of that said, I can think of another reason to punt. I can think of another reason to punt that's a good reason. Here is that reason. Sometimes you have code like this right here, where you dereference several things in series, right? And if you just naively generate code for that, you're like taking the address of the struct, adding a constant, adding a constant, adding a constant, adding a constant, right? That's what that looks like. And the question is, what is your compiler's philosophy about how to optimize that? A lot of languages based on LLVM or whatever probably just emit those instructions and let the backend optimize it out. And the problem with that is it's slow. It's slow because you generate the instructions and then have to clean the instructions up. And until they get cleaned up, they act as noise, preventing you from cleaning other things up and so forth, right? A more old school, Dragon book thing to do is to try to notice constant sub-expression stuff and like just notice that you've already done that dereference in the previous line or whatever, and then just share that L value and then just add a different amount onto that. But a better thing to do, this is solidifying this into my mind. The better thing to do is actually just to say, look, if you're saying A.B.C.D here, that's, the compiler can do a limited kind of constant folding there, right? In the front end, it can just say like, look, I know that these are members of the same sequence of structs successively, and I'm just going to track where we are in the global struct. And so when we emit to the back end, it's just one instruction, and it's much faster. And so that would get shared with the functionality that we are doing right now, because that both that recursive case and the using case would be handled by that. Now that would be an equivalent amount of complexity to what we're doing right now, but the reason it's better, actually it would be less because it would be automatically recursive because of the order in which it's tracked. And the reason that would be better is it wouldn't just apply to one tiny corner of the language like this feature that I'm doing right now. It would apply to all code generation, right? Like all code generation of struct dereferences by more than one level would be improved by this thing. Which honestly sounds pretty good to me. So I think the value of doing this bit that I've done so far today is that I now get to comment it out and punt on it, but we get to put a comment in the file about why we're punting and what we're going to do later that's better. And that is how you make a good compiler. All right. That is a win in both compile time and debug build execution, right? Definitely in compile time. In debug build execution, well, big win, it's hard to say. Is it a small win? Probably. In debug build execution, it probably depends, because most debug builds do run a small amount of optimization. And the question would be whether it includes that or not. Would a sugar-powered using be less powerful? No, I think it would be equivalent. Everything that is constant gets killed when you use SSA form anyway. Yeah, but that's what I'm saying is that doesn't happen magically. Like, you generate all the intermediate values and then notice that they're constant from each other and then collapse them. Right? I think. It depends on your... Actually, that could be another way of doing it, is just your representation... hard to say. All right, so I have to comment this back out and maybe go put a comment in the file about why this isn't the case right now. And then I have to go fix this other bug that I noticed about something I did wrong in the last beta that nobody's complained to me about yet, but is definitely wrong. I think. Create add 5,3. Yeah, but that's not what it would look like. It wouldn't look like create add 5,3. Because you're starting with a value that's not constant, right? You're starting with like an L value of something that's on the stack. And then you're adding to that. So it's more like you have something that's add L value, comma 8. And then you do an add with that with 16. And you want to notice and collapse that. And that might actually... not be hard, but you did generate that node before that, right? I mean, maybe if you know that nobody else is referencing it, you can just write the new value and it's not slow. Like it depends on implementation details. Okay. Here we go. It will have I like that. All right. So we aren't doing this. Here, I lied when I said it's pretty straightforward for the compiler to know the address of members. Well, it is for the simple case. It's not for the complicated case. For now, addresses of struct members are not constant because compiler implementation details make it inconvenient. The plan is to change some of the way the front end works to make this nicer and more natural language. We will make, in the meantime, you can adding an integer offset to the pointer, but don't forget that pointer math multiplies by the size of the type. Okay. So that is what our punt looks like. And we've just got a to-do list here. Okay. So that's good. Okay, great. Look at all the things that are constant, though. Look at all those. There are a few more that we want to get, but that's great. Okay. This is probably good. This file contains a bunch of examples of things that are guaranteed to be evaluated at compile time as constant expressions. For an explanation of why this is useful, see that, which we also okay. Tell is the routine we will call a bunch of times to tell us whether a particular kind of expression is constant or not. Okay. This improves the programmer's morale in the sense that, what do you call it? The programmer's confidence that these kinds of operations will not incur any runtime cost. There are also language semantic reasons to know what's constant as covered in 550, right? Okay, so that's probably a good enough explanation for now. I'm going to run the tests in debug mode, which will take a minute. And then we'll do it in release mode. We won't check this in yet, though, because I have a no check, although maybe. Oh, we've got some no check-ins. Oh, my gosh. Oh, this part. Okay. So part of what we're doing, I did this substitution thing up here. I changed that, and we're just verifying right now that that didn't break anything, among other things. Serious Sam 4, is that out today? Well, right now we're working. So there's no Serious Sam 4 while we're working. Okay, this is the bug that I wanted to fix. This whole offset of is has to get commented out. Actually, no, it's just going to get deleted. We're still compiling. That's the bug I wanted to fix, and then this is something I wanted to check. So good. We have two no check-ins. They are things that we will do, and then we'll check in. I don't know what to think about Serious Sam 4 because Serious Sam 2 and 3 were just, they never captured the magic of Serious Sam for me. But we'll see what Serious Sam 4 does. All right, so that passed. Let's do this one. Right, so okay, that is the right answer. So we are dividing by, this is a pointer subtraction, right? And we're dividing by the size to get 5 elements. And then, of course, we did a minus b, so it's minus 5. What if it's... I assume that I make it 1 even though size of void is 0. Yeah. Okay. That's what I expected. So I handled it. Whether that size of 1 thing is the right answer, I don't know, but for now that's fine. So this is the thing that I want to fix. Actually, you know what? This is correct. There's no bug here. Yep. All right, so we're going to do release tests. And then we'll check in and we'll do a little more documentation. And then ship the beta. Talos Principle 2 is definitely still happening. Well, if I were doing Talos Principle 2, and I'm not, and I don't know anything about it, but I would make it the same framework that they have about how you move around and find puzzles, but I would just make the mechanics totally different. Like, I wouldn't have it be like lasers and things on buttons, right? Because if you're just going to do like more lasers and things on buttons, it's going to be really hard to do that in a way that's good. But if you came up with different primitives, then it could totally be Talos 2, right? Ship it public? No. Why does everyone ask? No, we're shipping to the privileged 0.0001%. We're shipping this beta to Jeff Bezos and Bill Gates and Warren Buffett and what's his name? George Soros. Jack got you excited. Yeah, okay. Yeah, I do think we're not that far from expanding the beta, but again, expanding the beta will be like doubling the size or something, right? Which is still not that big. Jeff Bezos. What does the roadmap look like for the next 12 months? I don't know. Like, there are items on the roadmap in terms of functionality. I'm not being that strict about what order they happen in. That's all. When's the website coming? I don't know. I don't know. I already have more website stuff going on than I want to deal with. Okay. So we're running release tests right now. Bam, bam. Game runs, hopefully. How many people are working on the compiler? Right now, it is just me. That number has gone up and down over time. Imperative programming is a mess of incidental complexity, said someone who... What's the most complicated thing you have programmed? I'll answer that with a question. What's the most complicated thing you've programmed? And don't say factorial. Work on constant expression evaluation stuff. All right, so really the last thing I really wanted to do... Oh, there's a no check-in. What? In this one... Oh, yeah. Yeah, we punted on those. Oh, although... Okay, we have, before we do the last documentation, we do have to test something. All right, let's make sure that doesn't break. Oops. Come on, type. Okay. Let's just put something in here. No check-in thinger is 5. So what I just want to do is test this. See, this is through a dereference, but it's a module dereference. So this is just still a regular global variable, and that is supposed to work. If that doesn't work, we got to fix that before we ship the beta, because that's just bull puckies. 50-50 that this works. It worked. Great. Ship it. Okay. What's the most complicated thing I programmed apart from this? Probably the witness, my part of the witness, right? I certainly didn't program the witness by myself. There were other people doing a great deal of work on it as well. All right, we're not going to feed the language flame war trolls. That's a bad idea. Okay, so I just wanted to go to 550 is constant, and just, this is, I just pasted someone's email in here before, and I just want to write a better thing. Okay. The compiler, let's go claim that we did this, right? See, I already declared that this is going to ship today, too. I could wait till 25 September, so it's beta 25 on 25 September, but we're not doing that. We're going to ship it. Do I plan on creating other software besides games? Maybe. Who knows? Who knows? It's not clear to you how one is supposed to manage paying the rent and putting food on the table while trying to make a game. Let's say that that person isn't presuming that his game will succeed but has good faith and can't do something on the side because it would affect his execution. Well, you got to get funding in that case, right? I mean, look, getting funding for a game in the current environment is easier than convincing people to notice your game and buy it from you, right? So consider that a test. If you can't get funding for the game, you probably aren't being proactive enough to be able to get anyone to buy it either. You know what I'm saying? I'm going to warm up some Bengal spice and we'll write this. I just don't want to do any more caffeine, man. Oof. Buying the game from the Unity Asset Store could definitely be a winning strategy as well. Will this be open at some point with me as the maintainer? I really strongly despise current open source culture, so we probably won't ever run it that way. The whole thing about like I'm a maintainer and everybody poops on me all day is like just not... That is some Atlas Shrugged shit right there, and I refuse to participate in that. So, yeah. Do people usually live off the funding? Yes, that's what it's for. When you get funding for a game, it's mostly so you can work on the game, and then secondarily so that you can pay other people to contribute to the game, like making, art or whatever. Did the guy in the email miss the dollar to make the MSert into 2 versions at compile time and a runtime? Yes. And I actually mention it down here. Like, this is not that great of an email because you can't look at it as an example of what to do, right? So that's what I'm actually going to explain here is what is constant is for. Just like current open source culture is like, it's all about 99% of people being entitled brats. Like, I don't even know what it is. I don't understand how people let it get to where it is. I just have no desire to participate in that at all. How much hand-holding do I find myself doing in the art process of the game? It varies, like at the beginning of a project a lot, because what you're really doing is getting everybody on the same page and understanding what the game is. And then later on, when everybody kind of gets it, people can more cruise along without having a lot of discussions about what we're doing. Okay, so the compiler evaluates certain kinds of expressions. Okay. This being a statically type-checked programming language, a certain amount of information is available at compile time. This is to, what is an intro that's not just like saying a bunch of words? Okay. One advantage of a statically type-checked programming language is that a fair degree of information is known at compile time above and beyond the basic types of the variables. For example, if you have code like, let's just do this style. Do I actually let you do that? I actually don't know if we need an autocast on that or not. Let's see. Yep. Let's take the enum out, because that really, let's just say so it won't emit runtime code to do the addition operation it will just put 44 into the output code. Okay? That's kind of the role of, okay, it's kind of the role of a code optimizer to do these things, but when things are known to be constant like this, the 44 can be generated by the front end before we ever get to the optimizer. This is nice because we know that we won't generate extra slowness in a non-optimized debug build. Speed of debug builds is pretty important sometimes. And that we won't slow down the generation of release builds by giving the compiler's back end, the compiler's optimizer extra garbage that it has to figure out. Okay. But there are also good reasons to know whether something is constant from there are some language features that require constant values as arguments. So knowing whether something is constant lets you, helps you trying to do this on a day when I didn't get enough sleep is not good. See, this is a little bit weird because we're probably going to have little how-to pages for each of these language features. So we don't want to go super deep on them. Helps you know can be used when. The next how to 551 things that are constant goes through a survey of different kinds of things that are known. Because those language features happen in the front end long before the code optimizer even has any code to optimize. Goes to a survey of different kinds of expressions that are known to be constant. Here we will look at some of the language features that use constants. Here we will introduce the built-in expression is constant that may interact with is constant. Okay. Okay, so is constant takes an expression as an argument and tells you if that argument has a value that is known at compile time in the front end and thus can be used with the various features that require constants. You can use it like so. Is constant 3. Put our import basic down at the bottom. Take this out. Juice, use it like so, just use it like so. It's nap time soon. Wow, I did not get enough sleep. We're going to ship the beta, though. You know what? I'm going to take a short break from writing and let my writing brain rest for a second. And we're going to build the Linux executable for the beta. because I can, I can check that in and then go back and finish editing this file. I was typing stuff and I was like, wow, that part of my brain just wants a rest. All right. Hopefully this will go smoothly. I tested this on my Linux laptop this morning before the stream to verify that we didn't break anything too bad, and it seemed fine. That said, this is a different compiler version. It tends to have different opinions about some things. Boy, compiling in a VM is slow. I think it only gives it one core to work with. I need BFG division to wake me up, maybe, but I think the winning strategy is to do this stream, take a nap, and then wake up and do a second stream. And the more I BFG division, the harder the nap will be to do, right? All right. Okay. So as long as it passes these tests, we can check in that executable. Why do I run Ubuntu in a VM? I heard the WSL 2.0 works quite well. Because I don't want anything to do with that. It's stupid. Like, if people don't understand what that is, I don't know what to say, first of all. Secondly, the reason I have this set up is because, well, it's a long story. Like, this is at least a relatively straightforward way of keeping the dependencies something, because Linux is a pain in the butt about like binary dependencies. So this is keeping them at least something known that a lot of people can deal with and run with. Later, when we frickin' get it going on Alpine Linux or whatever, it'll be even better because we won't have that problem at all. But that's, as far as I know, that's going to be something that would be pretty hard to do on WSL. I think I can set up the core count in the VM settings. Yeah. Yeah, probably. All right. Well, that's most of what I need to do there. I mean, this will get double checked by the packaging. All right, bye VM. That was not a very long break from writing. All right. Result factorial How many times have I written factorial in my life? All right. Whoops. If you want to succeed in the game industry, return an integer. All right. So okay. Two basic language features, if and assert, require arguments that are constant. I just don't know how to explain this. Like, I'm kind of in this trap where I'm explaining things dumbed down, but it's not getting to the essence of what this is really for. Okay, let's do baking first. The features that let you bake procedures one example of a feature that requires constants is bake arguments, which allows you to recompile procedures with some of the arguments substituted. into simpler ones. I don't think we have that yet. No, that would be later. What's a good example of a thing where I should bake an argument? I always, in the earlier demo that I did, I always had a thing that adds two numbers. We could just do that. Adder, x is an int, y is an int, result is an int, right? Let's just say int. Return x plus y. Okay, add 42 is bake arguments adder y equals 42. In this case, the 42 must be a constant. Expected identifier. Whoops. Is that how I do it? Wait. I don't remember now. Okay. We are not calling bakes yet, though. We didn't wake and bake. Okay, adder 42 of 11 is 53. How is that for an advanced language feature, jerks? Okay. One nice thing about baking arguments in this way is that the optimizer can focus on making the body of add 42 fast. Without worrying about it being inlined. Sometimes this can be very helpful if you sometimes this can be very helpful if you want to put some It's like, how much do I really want to go into bake right here when there's going to be a whole tutorial about bakes, right? So I want to put some conditionals inside the procedure that depend on the value of the baked argument. They can be optimized away when the argument is baked. These tests. Okay. That's all about bake. That's not about what we're talking about here, right? Okay. Okay. I feel like this is going to go off in the weeds. Baking a singleton into a call. I mean, sure, but this isn't a bake demo. That's the point. Like, I'm trying to say as little as I can about this. This isn't really about baking. It's about asking if things are constant. Didn't the polymorphic procedures demo become a documentation file? No, because somebody frickin' destroyed all my demos. And I'm very angry about that. I have to go recover them at some point. But I'm using this kind of thing as just an example. Because, you know, if I just went back and copied the demo, that might result in things not being explained as well sometimes. I don't know. We can use See, this adder function is a little bit too dumb. Now I want to think of one that's a little bit like one step up, right? So how about divider? X is an int, y is an int to an int, right? If is constant y, assert y is not equal to 0, right? Else, assert y is not equal to 0. because it's much easier to catch errors when you don't have to exercise some code path to find them. If we can't assert at compile time, do it at runtime. All right. Return x divided by y. Okay, so alpha is divider of 15 by 5. Right. Div 7 is bake arguments divider y equals 7, right? Um, 99, right? So that'll be, what'll that be? 14, right? Uncomment the following bake to see a compile time error. We leave it commented out so that we can successfully and run this example, right? So like, all right, so here we're just going to say div 0 is bake arguments divider y equals 0. All right. Whoops. Okay. There we go. See, this is why it's hard to explain, because it's about all these features operating together. it's not, yeah. All right. Anyway, compile time assertion failed. This doesn't actually tell us where it came from. That's not good, but you know what? We're not going to worry about that right now. All right. Yeah, the problem is you can't have static assert in the code at all. Right. Okay. the if is constant y ensures that we will only attempt to compile the assert when it is valid. Okay. The auto baking feature is a more streamlined version of what we did in bakes above. And it starts to become even more apparent why you would want is constant. Okay. The dollar before y means that if anyone calls this procedure with a constant argument for y, the compiler should automatically bake a specialized version of this procedure. But if the argument is not constant, just use the regular version with both x and y being runtime arguments. All right. Okay. Right, so we could just say alpha equals divider 15 comma 5, beta is divider 99 7, gamma is divider factorial 120 comma 5, right? Delta is divider minus 1 2 3 4 comma 0, right? Oh, we got to put factorial. Okay. Compile time assertion failed. What we should fix, we're not going to fix this in this beta, but should give us the calling site, because without that it's very hard to fix. All right. I mean, it's easier, like if the assert is in the body of a function, like where it's happening directly, it's not a problem. But here it's like, it's being generated by a procedure call and so forth. To see the assertion fail. All right. Great. So that's sort of what all this massert stuff was. Like, we've pretty much just explained it all. So Now my question would be to go to the audience. Oh, we should explain. We didn't do this. Auto bakes, and then I want to do declarations. We want to have a little explanation in here. All right. Wait, why is gamma 0? Oh, because factorial of 120 overflows. All right, great. Got a question. What is your question? National Punctuation Day. That's a good day. It's true that we use semicolons every day. What is the question? Can you rewrite assert? Why do you have a bunch of apostrophes? Are you using a Japanese keyboard that's going crazy? Can you rewrite assert to use is constant to try to evaluate the expression with assert or do a runtime check otherwise? You would have to make, you probably could do that. The thing is, assert would have to be a macro that expands to insert a run. Wait. I mean, it would have to be a macro. They wouldn't have to insert a run. It could be a macro that does that, yeah. Do you need to learn all the languages out of your head? No, just learn one programming language and be really good at it. And don't make it be HTML. Can you rewrite LLVM with your girlfriend? Not today, apparently. All right, I warmed up some tea water before, but then I ended up drinking one of these. So I'm going to go warm that up. Okay, any on-topic questions about what we are doing here or suggestions on where this should go? Because I know what I want to explain here, but then after that, I'm not sure. Is constant only works on variables, not... I mean, it'll work on an arbitrary expression. It just has to be a constant expression. It would be helpful to show that is constant is evaluated at compile time, even with possibly non-constant arguments. But we sort of did that at the very beginning, right? Where we said is constant factorial 5, right? Oh, but... Okay. It is important to understand that the value of is constant is always going to be either true or false, and it will be known at compile time even if the argument is not constant. That's a good point. I was going to say that and then I forgot, right? In other words, is constant x is true for all x. Right? Is that kind of what you mean? You often use if platform is equal to Xbox or whatever. Is there a Switch version? There isn't right now. That would be a straightforward extension. It's just we haven't done it. Is hello world constant? Yes. And we actually have this whole file, this 551 file here goes through a ton of stuff that's constant. And yeah, strings. Strings are absolutely constant. Couldn't the optimizer figure all this out with having to use is constant? Read this part while I can make my tea. Can you bake a function that takes some function as a parameter so the parameter function is constant and more optimizations can happen? Yes, absolutely. Does the argument need to be evaluated or is it just checked? It shouldn't be evaluated. That is a good thing to talk about. Let's do this. It is also important to note that is constant does not evaluate evaluate its argument in the sense of executing code. It just tells you whether that thing would be constant or not. In the sense of generating code that would be executed at runtime or not. In this way, it's like what's another thing that does that? Type of right. And several other language features. Is constant print hello sailor. This will not print anything. This will not assert. Right? Hopefully, yeah. See, I'm not a totally incompetent programming language. Would is constant run send nukes send nukes? Yes, that would send nukes. We should say that. How do I explain that? features like run. The whole point of run is to generate a constant. So if you put run inside is constant, that run will indeed run. You know, maybe I should explain this stuff. I'm not sure if I should explain this stuff at the beginning so that people like get what's going on, or if I should explain it later because these are picky details and you don't even know what this is for yet. You know what I'm saying? So C is constant, print goodbye Mr. Goodbar, I don't know. Except he didn't do it. I lied. I lied about, wait, what? Did I lie to you? I did. Oh no, it did. It printed it. Right. It does it at compile time. That's why we didn't see it. I was looking down here. I'm like, why isn't it there? It's because it's there, dumbass. All right. In my defense, it says in the stream title that I didn't get enough sleep. Okay, great. We're not going to print that. Okay, so we've said some basic stuff about, don't you wish that people who made things would document them? Wouldn't that be great? All right. So the thing we want to say here is, again, it's important to emphasize that is constant is not about things that might happen during code optimization, and it's not about things that seem obvious to a human looking at the code. Rather, it's about constraints that are guaranteed by the programming language semantics. For example, if you declare an identifier with : the expression on the right-hand side is guaranteed to be constant because compiler checks this. Thus, any uses of that declaration are also constant. If you declare an identifier with : that identifier are also constant. That identifier will not be constant even if it looks obvious to you that you know what the value would be at runtime. What the value is at runtime. All right, so here we'll say x : run factorial 5, right? Let's do a simpler one. Let's go x is 1 plus 2 plus 3 times 4, right? plus 5. Okay. Compound expressions between constants by constants, which is why this code calling successfully, right? So we're going to do that. We're going to do y. Uncomment this declaration of z to see a compile time error. You can't declare a constant identifier with colon if there is a non-constant expression on the right. Okay, so we're going to do that. It's a little bit redundant with what's in other things, but I guess that's fine. There we go. Claims to be constant uses an expression that is not constant. Okay. A colon equals 7. 7 is a constant, but A is not because we used equals, which means it is mutable. All right. So okay. Do we have any other ideas about what should be in this file? This is that seems like enough. So the desire isn't really to make it longer. The question is just, are we missing anything that we ought to explain to people? A note about macros. I mean, so A, it's not super relevant, and B, macros are probably still going to change substantially, so I don't want to write too much about them right now. Are X and Y on the stack or .r data? You mean the capital X and Y? Not really either. Because you don't, like, this is just 20, right? This is just the number 20. And so the compiler knows that's the number 20, and if you use it in a way, like if you said factorial of X, you would end up putting a 20 somewhere, right? But in this case, that 20 never actually appears at runtime at all. It just exists, right? Because nobody ever... Like is constant doesn't care that it's 20. That doesn't generate any code, right? Would it? Yeah. Is there some function declaration notation similar to const expert in C++ with which you could potentially put factorial without run? I mean, not really. Like the C++ constant expression evaluation stuff is super complicated, right? And annoying. And we don't really do it that way. So what we do is we have simple things that are evaluated as constant that the programmer knows and can predict are constant. And then if you want a complicated thing, just do compile time execution, right? And that's much more powerful than the C++ thing, right? Like I don't know what it looks like like, wouldn't to write factorial in C++ at compile time, don't you have to use like variadic templates or some crap like that? Like, it would be a disaster, wouldn't it? I don't keep up on C++, so who knows, but constants don't exist at runtime. Does this mean you can't index a constant string with a mutable int? No, that would be fine, because when you index the string, that causes the string to exist at runtime. That's fine. It's just in this case, this X doesn't need to exist at runtime, so it doesn't. That's all. Can I show the implementation of isConstant? Well, okay. So we have this query isConstant, right? So this is just the outer part of it. There's an AST node called query, and it handles like type of and size of and all this stuff, right? So if we get here, it's an isConstant, and that just calls this thing that says eval expression to literal or constant. This is the same function that gets used all over the compiler, right? So if we got something back from that, we return true, otherwise we return false, and then set the type to bool, right? So that's pretty simple. So then this thing, what is that? That's a little messier. And there's a few different functions that do similar things, that whatever. So basically, let's ignore the bakeable global thing. I don't even remember what that is right now. Anyway, you call this and it's like, okay, what are the things? All types are constant, right? Because it's a compile time programming. You don't invent types at runtime. You can invent types at compile time and then they become constant after you've invented them. But you can't make a new type at runtime. So all types are constant. Procedures are constant. Literals are constant. These directives that produce values are constant, right? Imports are constant. This is just here for, I don't know why this is just here. This is like probably, this probably shouldn't be here, honestly. This is old. This is a syntax tree node that does exist, but the way in which it exists now probably doesn't necessitate it being here. If you have an identifier, we do some weird stuff. So if it's bound to some overloads, we actually say that's not constant right now, even though it kind of is. It's like a set of constant functions. And the reason is because we like don't have language semantics to represent a set of constant functions. Like, do we say that the type is like a product type of all the function signatures, or what? Like, I didn't want to get into that. So like overloads are kind of not constant right now. That might come to bite me in the ass later, but it is what it is. If an identifier is bound to something, then, we say, what is it bound to? Again, I forget what this bakeable global thing is. Oh, the bakeable global thing can probably go away because pointer literals, right? This was from before. This let you bake things with the address of something before we had pointer literals, right? So that was just in there, to let us do a little more than we otherwise would, right? Okay, structs, enums, those are constant. A cast, this really shouldn't be here. So I'm going to put that on the list. Like, this is constant expression evaluation on the cast, but we're doing it here instead of elsewhere. And I think the reason why is because we generate implicit casts all the time, and then maybe in some cases would fold that down. But really what we should do is just any site that generates an implicit cast should maybe fold it down. But I think we do it here. So this is actually a bunch of code to be like, if we're casting a number or a string or whatever, right? And then this is what kicks off that bakeable global thing. This is like, if we're taking the address of a global, that's a constant for these purposes if certain flags are set. And this, I think, can go away now that we have pointer literals, because that would evaluate into a pointer literal anyway. Okay. Are non-overloaded functions constant? Yes, they are. And it's not that the function is constant or not. It's that what you collected as a result of the identifier lookup is constant or not, right? That individual, like you could have a function in the same namespace with 3 or 4 other functions of the same name, and as long as you pick that one out, it's constant. And you can do that. There's some directives that like let you do that to resolve the overload without calling the function, right? So this works, A::A::A, but this doesn't. What? I mean, the first one works. No, both. Oh, I see. The second one has an overload. I mean, let's see, right? I'm pretty sure that this doesn't work, right? Like, we could just put all this here. So that's one overload of B, that's another overload of B, and we're defining that. I believe that that doesn't work, right? And that's why I'm saying that might bite me in the ass. Wait, oh, because we have this down here. Common variable names. Oh, that did work. I must have an exception for that when we're doing constant declarations. What happens if I print that? Type tag 9. Print doesn't know how to handle it. It's not corrupted. It's just overload set. So the print function doesn't know that these are overloads. You know what? We could fix that because that's not even a binary change. Because we already compiled the Linux binary, but like so it's not corrupted. It's right. So we're just going to do that. Whoops. I left a paren. There we go. So, and then if you wanted to resolve that, you could do the following. You could be like, resolved is procedure of call B of 5, right? I don't know if print will print anything that useful for it, but yeah. So resolved is a particular procedure, and that's the pointer to it, right? So this is how you get something out of a bunch of overloads without actually, like, we didn't call B. See what I'm saying? How can you dynamically compile functions at runtime? By linking a compiler to your program. I think it would be cool to add some examples of real life situations where you should consider using these features in the doc. Yeah, maybe. I don't know. It depends. Sometimes those get quite large, and then it's not byte size anymore. So B here just becomes an alias for B, yeah. I mean, yeah. So what procedure of call means is it just says, I'm going to write a function call, but don't call it, right? It's kind of like when we were just saying is constant doesn't call it, right? Procedure of call also doesn't call it, but it just tells you what that procedure would be. Or, you know, I could go hello sailor and it'll compile time error because that, whoops, that doesn't resolve, right? Procedure did not match any of the possible overloads, bam, bam. So that's a very useful feature. Like when you want to do that, it's golden, right? Can be non-constant. No. So right now, overloads have to be constant. I did originally support non-constant overloads, but it was a bunch of additional complexity and didn't seem worth it. So I took it out. Why is constant not a directive like other stuff that is evaluated at compile time? I'm just a little bit inconsistent about these things, right? Like, should like size of and type of all have hash marks in front of them? Maybe. Like, that would be the most consistent thing. It starts feeling a little bit syntax spammy eventually. But it would be more consistent, yes. And so why did I make is constant be more like size of where it doesn't have a hash? I don't know. It's just, I'm not that worried about syntax right now because we're gonna revamp it later. Can you do procedure of call with types as in B of int? No. That is actually how it used to work, and I didn't like that because the thing is, types could be really complicated, right? Like the argument could be like a struct that takes a bunch of parameters. Like who frickin' knows? Like it could be a really like types in languages with, you know, both type inference and generic programming and all that. The types can get long sometimes, and you don't want to force people to write types if they don't have to. That said, could we put back a variant that works that way? Sure. Like if people really want that, it's not hard to add. It's just I used to work that way and I changed it. Recently, you've gotten a ton of joy from the C# question mark operator check for null. How do I feel about it? I started implementing that at one point, and then I realized, like, it's not actually that useful in most of the code that I write. Well, I don't know what question mark equals does, but I was going to do, like, question mark dot or whatever, and the thing is, that kind of code... That kind of operator is more useful if you're in Object Town and you knew tons of objects and have them point at each other all the time. But you really shouldn't be writing code like that in the first place. It's bad coding style. So once you're not newing tons of objects all over the place, it's like, well, it's a minimally useful thing. It is still maybe a little bit useful, but I don't very often find myself typing code and wishing that I could use that. Would you have to write the types if you could just write type of val? You can't. So that's the thing, is you can't really do that. Like there's no way to say right now, like type of B.A. And then especially not if it's an overload set, because the arguments could have different names and what, like, you know, like there's no way to say that. Did procedure of call need to be differentiated from type of? I don't understand that. They're different things. This is not telling you the type. It's telling you the actual procedure that you can then call. This is not about the type. What do I think Go gets right about types? I don't know. I don't know what Go does with types. I think Go is just very simple with types, right? Wouldn't type of proc A get the type of the return value? Yeah, it would get the type of the first return value. That would be ambiguous for B T colon type. No. You mean here, like if I add another like that? That should still work. Hold on. Well, the hello sailor won't work because there's still no string version, but like, there's nothing magical about type, right? So that'll resolve to a different one, and then pointer to int, that'll resolve to a different one. If procedure of call also accepted B of int. Oh, right. Yes, I see. Well, that's one reason why I didn't do that, right? So if we did that variant where it accepts the types, we would either have it be a different directive name or it have a modifier on it. Because yes, you can't, yeah, like if the argument is a type and you put a type, yeah, that's ambiguous, yes. Does Sean contribute to the language? No, he's off doing his own stuff. Are we fielding general language questions? Maybe. I feel myself growing very tired now, so I think I need a nap to get back some of the sleep from last night. But the question is, do we need anything else here? Or are we done here? Does anyone have... We can do very concrete suggestions here for a second, and if nobody has any, we can call that the beta, right? Let me commit this for a second anyway. What's like, why can't I get this window up to the front? Like, it's 2020 and Windows has race conditions. Oh, and also print. Yeah. Can you instantiate a variable with a type with the result of a type of expression? Yes, you can. You're like this, the following. We'll say proc colon type of resolved. That's going to be null, right? But it'll be null of the type of resolved. I actually, what happens if I do, I'm not actually sure what happens if we do this, where B is an overload. It's probably still null. I don't, or maybe it's an error. Oh, that's a compile crash in LLVM. Great. Yeah, that's a compiler crash. We're not going to hold up the beta for that, but we're going to have to fix that. We're going to have to fit. That's a priority. Priority fix for next beta 26. How many people are currently in the beta? About 20. All right. I think that's it. I think we're done. Let's run the... Oh, hold on. I want to update the Windows executable, which should be... actually... Come on. There's the Linux build. There's the Windows build. And it's today's, hopefully. I mean, I changed the version a little bit early. So let's just double check that it's been checking it in. Build passing, build. Okay, yeah. So it's got all the things. So make distribution. This is how we ship the beta. Done. I mean, it's not shipped, but it's packaged, so. Yeah. It even checks, so this version stamp down here, it actually checks the Linux executable and the Windows executable and makes sure they have the same version string, byte by byte. That's how we prevent accidentally shipping the wrong thing. Have we ever thought about setting up fuzzing for the compiler? We had some fuzzing going before, but unfortunately it didn't seem to be a very high-powered fuzzer. Like, most of what it was exploring was just like super pathological garbage looking inputs, which there's some utility to that, to making sure that your compiler doesn't barf when you get those. But what you really want is to fuzz things that are very close to correct programs, right? Or things that are correct programs and making sure that they compile. And that just wasn't the fuzzer that we had going for some reason. So we don't really run it right now because it's not... It has passed its time of usefulness. Is a variable with type overload set assignable? No, it really isn't. Like, you shouldn't really even be able to declare it, right? And that's the thing that's messed up there, right? And so that's the question, is like, if we elevate this to being part of the type system eventually, then you would be able to declare it, but there wouldn't be an overload set type, right? The fact that there's an overload set type means that you can't really use it, because like different overload sets, like you need more information than that in order to do type checking, right? Than just that it's overloads. So yeah, it's kind of like a hack in the language semantics right now, that my feeling is that we're going to go all the way eventually and do that. It's just annoying, right? And we haven't needed to. Am I significantly more productive on desktop compared when using a laptop? Yeah. Yeah, just having a full-size screen is better. Especially in Visual Studio is horrible on a laptop. Like, it's just the worst. All right, everybody. Thank you for coming by. We shipped a beta. I'm probably going to stream again later today with trying to clean up some things. Maybe fixing that bug as well. Let's go see if we could raid somebody, though, because we haven't done that in a little bit. We can go to science and technology. Space and rocket review. Game dev. Do Lana, is she program? She's to-do listing. All right, well. Chicken life. Indie game devs charlando de videojuegos. I don't know, people. It's hard. Physics double and procedural generation. Okay. Well, or physics and I don't know. That could be a promising sign and maybe not. Let's port Checkanoid. What is Checkanoid?
Page. How have we got a 0 page?
Let's raid this. This looks fun.
So we've got temporary values up here, so it's
all right.
A good idea to use some of the...
Thank you, everybody, for coming by. And we'll see you later.